Hello class, welcome to Unit 3, Lesson 4. Today we're going to look at combining functions. We're going to be adding, subtracting, multiplying, and dividing functions to form a new one. And then we're also going to go ahead and look at composite functions. Okay. A lot about today is just kind of notation. You guys have done a lot of this stuff before. But when you see f plus g of x, it's equal to f of x plus g of x. What I like to tell people is math people are lazy. You get away with writing a little bit less when you do it this way than when you write it out this way. Sometimes you'll also see it as like just f plus g. So it's just saying take function f and add it to function g. Same thing here. But this is telling you to subtract functions. This is telling you to multiply the two functions. And then lastly, it's saying to divide the two functions. Biggest thing with division is it says you can divide as long as g of x doesn't equal 0. Why can g of x not equal 0? Because if it equaled 0, you would be divided by 0 and you can't divide by 0. Okay. The other thing we're going to do today is look at the domain of these functions. It is the intersection of the two functions. Okay. So it's where they intersect. That is their domain. So the first one, we got f plus g. So to find f plus g, we're taking this as function f plus function g. And in order to add them, we added fractions earlier this trimester. We need to get a common denominator. This function has a denominator of x minus 2. This one just has an x, so I got to multiply by x minus 2 on the top and the bottom. And then over here, to make it look the same, got to multiply by x. Now that my denominators are the same, okay, I would go ahead and say I have x minus 2, and then we put our numerators together. So I'd have x plus x, which is 2x minus 2. Okay, so there is f plus g. Then we got to talk about the domain. Okay, the domain is what numbers you cannot have in your denominator. Okay, so I would set the denominator equal to 0. So my domain, x, set each one equal to 0. So x cannot equal 0, and x minus 2 cannot equal 0. So x cannot equal 2. Okay, so for that one, my domain would be x cannot be 0, and x cannot be 2. Let's move on to subtracting. F minus g. I'd have 1 over x minus 2 minus 1 over x. Same thing here. I need to get a common denominator. So times this one by x, times this one by x minus 2. And now here you got to be careful. Because we are subtracting, you need to distribute that negative to both things. So I'd have x minus x plus 2. Your x's would cancel, and you would be left with 2 over x minus 2. Okay. And then my domain for this one, do you see how my denominators are the same as the one above? A lot of times they're very similar. My domain is that x cannot be 0 or x cannot be 2 by taking my denominator and setting it equal to 0. The next one is we multiply. So we got f times g. We got 1 over x minus 2 times 1 over x. And remember, when you multiply fractions, you just multiply across. So we got 1 times 1 is 1, and then you'd have x times x minus 2. And I would just leave it as a factored form. If you wanted to distribute it, you could. And then look at your denominator again. So your domain is x cannot be 0, and x cannot be 2. And then the very last one we gotta do is f divided by g. Okay, so function f, 1 over x minus 2, divided by 1 over x. When we divide fractions, we really can multiply by the reciprocal. So the top stays the same, and we flip and multiply by this one. So it's 1 over x minus 2 times we flip and multiply by the bottom. So x over 1. Now that I'm multiplying, I just multiply across. So I have x all over x minus 2. Okay. And then in this case, your domain, x for sure you guys can see can't be 0. Sorry, can't be 2. However, do you see how this was in a denominator at some point? Just that plain x. So what other number can x not be? X still cannot be 0. Okay. The other way you guys could think about the domain is you could think about them by themselves originally, since we're using both of them. Here, you'd see x cannot be 2, and here x cannot be 0, because you can't divide by 0. If I plug in 2 here, I would get 0. So that's why you got to make sure you include those 2 domain restrictions on all parts of these problems. Okay, so you could find the domain errors, domain restrictions right away, and then you could tack them on. There is example 1. Next one, your square roots. Okay, let's look at our domains for these 2 first. How do we find the domains of square root functions? Square roots, you cannot take the square root of 0, so x plus 1 can't be 0, so it means it has to be positive, so greater than 0, or it can be equal to 0. And if I solve this, x has to be greater than or equal to -1. So there's my first one. Then I move on to the next one. It's x is greater than or equal to 0 as well. So those are my 2 domain restrictions. This one's kind of hard to see. So we had x plus 1 is greater than or equal to 0, and then x is greater than or equal to -1. There we go. And as you saw before, it's where they are the intersection. So actually, let's graph this one out and see what happens. So -1 and 0. X is greater than or equal to -1. So we're here. And then greater than or equal to 0. And then it's where they are intersecting. Okay, so it's what they share. What do they share? They share from 0 onward. So the domains for these problems will be 0 to infinity. Okay, so that will be the domain for all of these, except for when we get to the division. You always got to be a little cautious and double check on the division. So we'll look at that one. All right, so here we got f plus g. Square root of x plus 1 plus square root of x. These are not like terms. If I had 2 square root of x plus square root of x, I could combine those to be 3 square root of x. However, they are not exactly the same, so I can't combine them any further. So there's my f plus g. And the domain will be 0 to infinity. Okay. Then we got f minus g. We got square root of x plus 1 minus the square root of x. Can't do anything with those, can't combine them, so that's it. Your domain will just be the same. Square root of 0, sorry, bracket 0 to infinity. Now we got multiplication. If I multiply these 2 things, I got square root of x plus 1 times square root of x. Now these 2 you can put together. The way you'd put them together is you can just rewrite them underneath the radical as 1 when you multiply. Okay, it's kind of like when we did square root of 5 times square root of 3. This could really be the square root of 15. You can break it apart that way. Okay, so just putting them together. And then the domain stays the same. Bracket 0 to infinity. Then the last one, we got division, f divided by g. Got square root of x plus 1 divided by square root of x. Okay. Here we would rationalize. So we times by square root of x on the top and the bottom. And we just did this numerator piece, so I'm just going to rewrite it. How we did that, x times x plus 1 all over x. Now you have to be cautious here. Do you guys see how I now have my square root of x in the denominator or just an x? So can x actually equal 0 in this case? Can I plug 0 into this function? No, you cannot. So a lot of people typically leave it all the same, but this is wrong. This cannot be equal to 0. So the actual domain is parentheses 0 to infinity. Okay, so all the adding, subtracting, and multiplying should stay the same for the most part. However, if you divide, you always have to take into account that you cannot divide by 0. And if I were to have 0 for x, then that would be an issue. So there is that. All right, your favorite actually, polynomials. These are the ones you feel the best about. This first function, f of x, it is a line. So the domain should be all real numbers. There should be no issues with this. And then the domain for this one should also be all real numbers, right? It's a quadratic, it's a parabola. Any polynomials, you guys, domain's always all real numbers. There's no issues with this one. So I have that. And then, so the domain would overlap. They're both all real numbers. So domain will be all real numbers for adding, subtracting, and multiplying. We'll just have to be careful with division, okay? So we go ahead and add f plus g. So I got x plus 2 plus x squared minus 1. Here you just combine like terms. So we got x squared plus x plus 1. There is my addition. The domain for this one, you just got to be careful. You can write fancy R, but I really want us to try and move to interval notation when we were writing out all real numbers. So remember that, so you can go all the way to the left and all the way to the right. So negative infinity to infinity. Then let's do subtracting. So we take function f minus function g. And with subtracting, you gotta make sure you distribute your negatives. So we got x plus 2 minus x squared plus 1. And then we just combine our like terms. So I got negative x squared plus x plus 3. And then the domain, negative infinity to infinity. Then we got multiplying f times g. So I got x plus 2 times x squared minus 1. If I were to multiply this out, I really have to FOIL or double distribute. So I got x to the third minus x, then plus 2x squared, and then lastly minus 2. Combine like terms, doesn't look like there's any terms in there, but I always like it if you guys could put it into standard form, so it's highest exponent to lowest. And then our domain stays the same. And there it is. Should have boxed these answers from before. There we go. The last one is f. This is one we just got to be careful with, the domain. So the last one's not f. The last one's f divided by g. So we got to do f divided by g. So I have x plus 2, and then I have x squared minus 1. So when we divide polynomials, what we want to do is make sure nothing simplifies. So what I would do is factor my denominator. So our difference of squares. So x plus 1, x minus 1. And just check, is anything that's in the top the same as the bottom? No. So everything is good here. The only thing I have to be worried about is now that I have a denominator, what two numbers can x not equal? If I set this equal to 0, x cannot equal negative 1, and x cannot equal 1. So our domain is all real numbers except for those two. Okay. So how would I put that in interval notation? I want every single number except for, whoops, that shouldn't go through there, except for negative 1 and 1. So my domain, negative infinity to negative 1, union, negative 1 to 1, negative 1 to 1, that's what I said, there we go, union 1 to infinity. So there it would be written out for us in interval notation. Now we're moving on to composition of functions, where you take one function and plug it into another function. Okay, I always say start with x, plug x into the function that is closest to it. So usually it's kind of like a backward method. So we'd have g of x, and you take g of x, plug it into f of x. A lot of times you guys like this notation better. You take g of x, plug it into f of x. Okay. So let's go ahead and take a look at this. So find the functions f of g and g of f and their domains. So f of g, not fog, but f of g. I need to take my function g and plug it into f. The way you guys like to see it is it's f of g of x. So we take g of x, the entire function, and plug it into any x's in f. Okay, so here is g of x. Taking it and I'm plugging it in there. So I will have, it goes in the spot of the x. So make sure you don't write the x twice. So x minus 3 goes in the spot. So I have x minus 3 squared. And then we would simplify. So we'd have x minus 3 times x minus 3. And I would double distribute or FOIL. So I'd have x squared minus 3x plus 9. So I got x squared minus 6x plus 9. So there is my f of g function, and then the domain. This is a polynomial. We loved polynomials because their domain is all real numbers. There's no problems. You can plug in anything to those. Okay. Then the other problem we need to do is g of f. So the way I would write it, it's really f being plugged into g. So here it is in the notation you like. So we're taking function f of x, plugging it into g. So now we're doing the opposite. Here's f of x, plug it in the spot of x. So I would have x squared minus 3. And once again, polynomial, so domain, negative infinity to infinity. That would be example 4. Example 5. We got f of x and g of x, and we're going to evaluate. So we have to find f of g of negative 2. First thing is you start with finding g of negative 2. So I'm going to go off to the side, find g of negative 2. Okay, here's function g. Wherever there's an x, I write a negative 2. So it's negative 2 minus 3, which is negative 5. Now, g of negative 2 is 5, so I have to find f of 5, which gives me 5 squared, which is 25. Okay, so my final answer for that one is 25. Now the next one, we got to find g of 3. So I plug in 3 minus 3. I get 0. Then I have to do f of 0, which is 0 squared. So my final answer is 0. Okay. Moving on to C, g of 1. Find g of 1. It's 1 minus 3, which gives me negative 2. Then I got to find f of negative 2. So I plug negative 2 into my function f for x. So it's negative 2 squared. Be careful. Any negative square is a positive, so the answer is 4. Then we have f of g of 0. So find g of 0. So I got 0 minus 3 equals negative 3. So I have f of negative 3. Because g of 0 was negative 3. So then I have negative 3 squared, which is 9. Okay, so there's example 5, A through D. Then let's go ahead and look at example 6. Same functions, a little bit different. So we got f of negative 2. So how do we handle f of negative 2? First, we find f of negative 2. Start with the innermost piece. So it's negative 2 squared, which is 4. So this part's 4, so then I have f of 4. I got to do it one more time, so then I would have 4 squared, which is 16. B, it's g of 3, so I find the innermost piece, g of 3. I'd have 3 minus 3, which is 0. So then I would have g of 0. This inside piece is 0. And then I'd have 0 minus 3, which is negative 3, and that'd be my final answer. C, I have g of f of 1, so I find f of 1 first. Find the inner piece. F of 1 is 1 squared, which is 1. Then I find g of 1. So I use function g, and I do 1 minus 3, which gives me negative 2. And last but not least, I got g of f of 0. So f of 0 would be 0 squared, finding that inside piece. So 0. So then I have to find g of 0. I already did that, but do it again. It'd be 0 minus 3, so negative 3. So there is example 6. Your homework is out of the book. Okay. Your bookwork, page 219 or PDF 248, 1 through 5, 17 through 22, 29 through 31, 38, 40, and 42. If you have questions, let me know. Otherwise, I will see you later. Have a good day.